Lesson 10.5, the Pythagorean Theorem. Our essential question is, how do you use the Pythagorean Theorem? We have 4 new vocabularies. The first one is hypotenuse. The hypotenuse is the longest side in a right triangle. Leg, or legs, the legs, are the other 2 sides. So they're the 2 shorter sides in a right triangle. In relationship to the right angle, so if I move my triangle over a little bit, and I draw in my right angle in the corner, the hypotenuse is opposite. It's across from that right angle, and the 2 legs, the shorter sides, make the 90-degree angle, like this. So the 2 legs are shorter, and where they meet with each other is the right angle. And then the hypotenuse, the longest side, is across from that right angle. The Pythagorean Theorem is the relationship between the 3 sides in a right triangle. The Pythagorean Theorem, you may have learned before, is a squared plus b squared equals c squared. And a and b have to be the legs. C has to be the hypotenuse. So A and B are the 2 legs, and C is the hypotenuse. The relationship says that the sum, if you square the 2 legs, so square leg A and square leg B, their sum has to be equal to the hypotenuse squared. A Pythagorean triple, then, would be 3 numbers, 3 side lengths that are true when you plug them in the Pythagorean theorem. So, for example, 3 side lengths that would be true for the Pythagorean theorem would be 3, 4, and 5. Because if you plug them in the Pythagorean theorem, the 2 shorter would be the 3 and 4, and the longer side would be the 5. So 3 squared is 9, plus 4 squared is 16, and that does equal 25. So 3, 4, and 5 are true when you plug them in the Pythagorean theorem. Okay, next. Find the missing length. Find the missing length. A squared plus b squared equals c squared. We'll start with our Pythagorean theorem because we've got a right triangle here. The Pythagorean theorem is only true for right triangles. Next, I'm going to label my legs A and B. We are looking for C, the hypotenuse. So if I substitute 3 for A and 4 for B, we should be able to solve this equation to see what value C is. On the left-hand side, I can simplify. 3 squared is 9, and 4 squared is 16. Because they're on the same side of my equation, I can add them together. So 25 equals c squared. And then the last thing we need to do is the square root. Remember, the inverse of squaring is the square root. So the square root cancels out the exponent of 2. The square root of 25 is 5. So 5 equals c. So the hypotenuse is 5. My next example, we're missing a different length. So a squared plus b squared equals c squared. Looking at my picture, the 10 is the longest side. It is opposite this right angle. So 10 has to be the letter C for the hypotenuse. I've got a letter B over here, so that means that 8 has to be A. So if I plug them in, 8 squared plus b squared equals 10 squared is what my equation should look like. Squaring 8 gives me 64, and squaring 10 is 100. Now, if you look at where the variable is, b squared is on the left side, and it's being added to 64. So I will need to subtract 64 because I'm trying to get my variable by itself. So b squared is now equal to 36. And then if I take the square root on both sides to cancel out my exponent, the square root of 36 is 6. Remember that when you're looking for one of the legs are shorter than the hypotenuse. So my hypotenuse was 10, so I needed to expect something smaller than 10 for the missing leg of the triangle. Okay, next. This next problem says find the length of the diagonal. A diagonal means that you're taking one vertex and connecting it to another one that is across the figure. So my diagonal I just drew splits the rectangle into two right triangles. So I've got a right triangle right here, and the length of this diagonal would be C, my hypotenuse, because it is the longest side of the triangle. It's opposite the right angle. So A and B are my other two numbers. So A squared plus B squared equals C squared, and A is 5, B is 12. We don't know the hypotenuse again. So 5 squared is 25, 12 squared is 144, and they're on the same side. So I can add them together. I'll get 169 equals C squared, and then take the square root of that. 13 equals C. So my hypotenuse is 13. It is longer than both of the legs, so that is what I expected. Okay, next. It says find the missing length, and it's got a picture of a sailboat. A squared plus B squared equals C squared. A is what I'm looking for. My right angle is right here. So 20 has to be my hypotenuse, which means 10 is B. So A squared plus 10 squared equals 20 squared. A squared plus 10 squared is 100, and 20 squared is 400. Because they are on opposite sides, I need to subtract the 100 to cancel it out. I do not add them together if they're on opposite sides. So A squared equals 300, and then the square root, A is approximately the square root of 300. If I use the calculator, because you probably will get a calculator on these, it's approximately 17.3. If you did not get to use a calculator, you could leave it the square root of 300, or you could try to approximate it like we worked on earlier. We just didn't approximate square roots that were quite so large. Okay, our next problem says determine if the measurements create a right triangle. So if these measurements create a right triangle, the Pythagorean theorem has to be true. So when I substitute the two smaller sides and the longer side, so make sure that you've got the longer side as C, the two smaller ones as A and B, when I substitute them in the Pythagorean theorem, it would have to be true to be a right triangle. 9 squared is 81, 12 squared is 144, and 16 squared is 256, I need to check and see if this is true. If I add 144 and 81, do I get 256? I get 225. So, because these are not equal, it is not a right triangle. It does not satisfy the Pythagorean theorem. Another one like that? Some of these common right triangles, hopefully you'll start to recognize. Plugging in the numbers on this one, keeping 10, the largest number, as my hypotenuse. 6 squared is 36, 8 squared is 64, and 10 squared is 100. If I add 36 and 64, do I get 100? Yes. So 100 is equal to 100. Yes, this is a right triangle. You should be able to write a summary now. And here are your homework problems.